It is not legal to put wires directly into the quick connects on receptacles and switches. The National Electrical Code, specifically Section 110.14 c, mandates that terminations of conductors in or on devices and fixture terminals shall be made in a manner that will prevent loosening due to vibration or creep. This requirement essentially means that wire terminations must be secure and reliable, ensuring a lasting electrical connection. The intent of this code section is to mitigate the risk of loose connections, which can lead to a variety of problems, including overheating, arcing, and even electrical fires. Loose connections increase the resistance at the point of contact, causing the area to heat up as electrical current flows through it. This heat can damage the insulation of the wires, the receptacle or switch itself, and surrounding materials. Arcing occurs when the loose connection creates a gap, allowing electricity to jump across the gap. Arcing is a significant fire hazard because it generates intense heat and can ignite nearby flammable materials. The National Electrical Code aims to prevent these hazards by requiring secure wire terminations. Screws and pressure plates are the generally accepted methods for achieving these secure connections. When a wire is properly terminated under a screw or pressure plate, it is held firmly in place, minimizing the risk of loosening due to vibration or creep. Creep refers to the gradual deformation of a material under stress over time. In the context of electrical connections, creep can cause the wire to slowly loosen its grip on the terminal, leading to the same problems as vibration-induced loosening. The use of screws and pressure plates provides a mechanical advantage that helps to maintain a tight connection over time, even in the presence of vibration or creep. While quick connects may seem like a convenient and time-saving alternative to screws and pressure plates, they are not considered to be as reliable in maintaining a secure connection over the long term. Quick connects typically rely on a spring-loaded mechanism to hold the wire in place. Over time, the spring can weaken, reducing its ability to maintain a tight grip on the wire. Additionally, quick connects may not provide as much contact surface area as screws or pressure plates, which can also contribute to a higher risk of loosening and overheating. It is important to note that the specific requirements for wire terminations may vary depending on the type of device, the size of the wire, and other factors. Always consult the manufacturer's instructions in the latest edition of the National Electrical Code for detailed guidance on proper wiring techniques. When working with electrical wiring, safety should always be the top priority. Always disconnect power to the circuit before making any connections or repairs. Use appropriate tools and techniques to ensure that all connections are made properly and securely. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to do the job. Ignoring code requirements and using improper wiring methods can create serious safety hazards. By following the National Electrical Code and using proper wiring techniques, you can help to ensure the safety and reliability of your electrical system. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest advances in technology and best practices. The National Electrical Code is developed by the National Fire Protection Association, a non-profit organization that is dedicated to reducing the risk of fire and other hazards. The National Electrical Code is widely adopted throughout the United States and is considered to be the authoritative source for electrical safety standards. Compliance with the National Electrical Code is essential for ensuring the safety of buildings and their occupants. Electrical inspections are typically conducted by local authorities to verify compliance with the National Electrical Code. These inspections help to identify and correct any potential electrical hazards before they can cause harm. In addition to the National Electrical Code, there may be other applicable codes and standards that govern electrical work in your area. It is important to be familiar with all of the relevant codes and standards before starting any electrical project. If you have any questions about electrical codes or wiring techniques, it is best to consult with a qualified electrician or electrical inspector. They can provide you with expert guidance and help you to ensure that your electrical work is safe and compliant. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. By following the National Electrical Code and using proper wiring techniques, you can help to protect yourself and others from electrical hazards. Furthermore, understand that electrical systems are not static. They change over time due to factors such as corrosion, environmental conditions, and normal wear and tear. Regular inspection and maintenance are vital to ensure the ongoing safety and reliability of electrical installations. These inspections should include checking for loose connections, damaged wiring, and other potential hazards. Any problems that are identified should be promptly corrected by a qualified electrician. When selecting electrical devices such as receptacles and switches, it is important to choose products that are listed by a recognized testing laboratory such as Underwriters Laboratories or Intertech. These listings indicate that the products have been tested and meet established safety standards. Using listed products helps to ensure that your electrical system is safe and reliable. Moreover, it is imperative to use the correct size and type of wire for each circuit. The National Electrical Code specifies the allowable ampacity of different wire sizes, which is the maximum amount of current that the wire can safely carry. Using wire that is too small for the load can cause the wire to overheat, which can lead to a fire. It is also important to use the correct type of wire for the application. For example, some types of wire are designed for use in dry locations, while others are designed for use in wet locations. Using the wrong type of wire can create a safety hazard. Additionally, the proper grounding of electrical systems is crucial for safety. Grounding provides a path for fault current to flow back to the source, which helps to protect against electric shock. The National Electrical Code specifies the requirements for grounding electrical systems. It is important to follow these requirements carefully to ensure that your electrical system is properly grounded. When making wire connections, it is important to use the correct type of connectors. There are different types of connectors for different applications, such as wire nuts, crimp connectors, and terminal blocks. Using the wrong type of connector can result in a loose connection, which can create a fire hazard. Also, be certain to properly support and secure all wiring. The National Electrical Code requires that wiring be supported and secured at specific intervals to prevent it from sagging or becoming damaged. Proper support and securing of wiring helps to ensure that the wiring remains in good condition and does not pose a safety hazard. It is also essential to protect wiring from physical damage. Wiring should be installed in locations where it is not likely to be damaged by impact, abrasion, or other hazards. When wiring must be installed in a location where it is subject to physical damage, it should be protected by conduit or other suitable means. Remember that electrical safety is everyone's responsibility. By following the National Electrical Code, using proper wiring techniques, and taking other safety precautions, you can help to protect yourself and others from electrical hazards. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. They can provide you with expert guidance and help you to ensure that your electrical system is safe and compliant. Furthermore, the topic of surge protection is relevant to electrical safety. Surge protectors are devices that are designed to protect electronic equipment from voltage spikes, which can damage or destroy sensitive components. Voltage spikes can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors work by diverting excess voltage away from the protected equipment. It is recommended to use surge protectors on all valuable electronic equipment, such as computers, televisions, and audio equipment. There are different types of surge protectors available, including plug-in surge protectors, power strips with surge protection, and whole house surge protectors. Whole house surge protectors are installed at the electrical service panel and provide protection for the entire electrical system. Regular testing of ground fault circuit interrupters is also critical. Ground fault circuit interrupters are safety devices that are designed to protect against electric shock. They work by monitoring the current flowing through a circuit and detecting any imbalance that could indicate a ground fault. If a ground fault is detected, the ground fault circuit interrupter will quickly trip the circuit, cutting off the power and preventing electric shock. Ground fault circuit interrupters are required in bathrooms, kitchens, and other areas where there is a risk of water exposure. It is important to test ground fault circuit interrupters regularly to ensure that they are working properly. The tests usually involve pressing a test button on the receptacle or circuit breaker. If the ground fault circuit interrupter does not trip when the test button is pressed, it should be replaced immediately. Moreover, arc fault circuit interrupters offer an additional layer of protection. Arc fault circuit interrupters are circuit breakers that are designed to protect against fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating a spark that can ignite nearby flammable materials. Arc fault circuit interrupters are required in bedrooms and other areas where there is a high risk of fire. These devices are more sensitive than traditional circuit breakers and can detect even small arcing faults. When an arcing fault is detected, the arc fault circuit interrupter will quickly trip the circuit, cutting off the power and preventing a fire. Regular electrical safety audits and inspections are a proactive approach to maintaining a safe electrical system. Schedule regular electrical safety audits and inspections to identify and correct any potential hazards. These audits and inspections should be performed by a qualified electrician or electrical inspector. They will examine the electrical system for any signs of damage, wear, or improper installation. They will also test the functionality of safety devices such as ground fault circuit interrupters and arc fault circuit interrupters. Any problems that are identified during the audit or inspection should be promptly corrected. Proper training for personnel who work with or around electrical equipment is invaluable. Provide adequate training to personnel who work with or around electrical equipment. This training should cover topics such as electrical safety procedures, hazard recognition, and the proper use of personal protective equipment. Trained personnel are better able to identify and avoid electrical hazards, which helps to prevent accidents and injuries. Furthermore, always be aware of overhead power lines. Overhead power lines pose a serious electrical hazard. Maintain a safe distance from overhead power lines when working outdoors. Never touch or come into contact with overhead power lines. If you are working near overhead power lines, be sure to use appropriate safety precautions, such as wearing rubber gloves and using insulated tools. When digging, always call before you dig to locate underground utilities. Underground utilities, such as electrical cables, gas pipelines, and water lines, can pose a serious hazard if they are damaged during excavation. Before digging, always call the local call center to have the utilities located and marked. This will help to prevent damage to the utilities and ensure the safety of workers. Electrical equipment in hazardous locations requires special consideration. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. Electrical equipment that is installed in hazardous locations must be specially designed and certified to prevent ignition of the flammable materials. The National Electrical Code specifies the requirements for electrical equipment in hazardous locations. When working in hazardous locations, it is important to follow all applicable safety procedures and to use only approved equipment. Regular maintenance and upkeep is crucial for a safe electrical system. Implement a regular maintenance and upkeep program for electrical equipment. This program should include regular inspections, cleaning, and lubrication of equipment. It should also include testing of safety devices such as ground fault circuit interrupters and arc fault circuit interrupters. Proper maintenance and upkeep helps to ensure that electrical equipment remains in good condition and operates safely. Consider the impact of new technologies on electrical safety. As new technologies emerge, it is important to consider their impact on electrical safety. For example, the increasing use of electric vehicles and renewable energy sources such as solar panels requires new safety standards and procedures. Stay up to date on the latest developments in electrical safety and adapt your practices accordingly. Proper documentation is essential for electrical safety. Maintain accurate and up-to-date documentation of electrical systems. This documentation should include wiring diagrams, equipment specifications, and inspection reports. Proper documentation helps to ensure that the electrical system can be safely and effectively maintained. Electrical safety is an ongoing process that requires continuous attention and effort. By following the National Electrical Code, using proper wiring techniques, and taking other safety precautions, you can help to protect yourself and others from electrical hazards. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. They can provide you with expert guidance and help you to ensure that your electrical system is safe and compliant. In addition to all of the aforementioned details, remember that proper selection of devices is paramount. Always choose receptacles and switches that are rated for the intended use. For example, if you are installing a receptacle in a damp location, use a weather-resistant receptacle. If you are installing a switch that will control a heavy load, use a heavy-duty switch. Using devices that are not rated for the intended use can create a safety hazard. Similarly, when replacing receptacles and switches, be sure to use the same type and rating as the original devices. If you are unsure about the proper type and rating, consult with a qualified electrician. Remember that making unauthorized modifications to electrical equipment can void the warranty and create a safety hazard. Never attempt to modify electrical equipment unless you are specifically authorized to do so and have the necessary training and expertise. If you have any questions about modifying electrical equipment, consult with the manufacturer or a qualified electrician. Also, be aware of the potential for electromagnetic interference from electrical equipment. Electromagnetic interference can disrupt the operation of other electronic devices. When installing electrical equipment, take steps to minimize electromagnetic interference. This can be done by using shielded cables, grounding equipment properly, and separating sensitive electronic devices from electrical equipment. Furthermore, the disposal of old electrical equipment requires responsible measures. Dispose of old electrical equipment properly. Electrical equipment contains hazardous materials that can pollute the environment. When disposing of old electrical equipment, be sure to follow all applicable regulations. Many communities have recycling programs for electrical equipment. Finally, the importance of education and awareness cannot be overstated. Promote electrical safety education and awareness in your community. This can be done by providing training to homeowners, businesses, and schools. By raising awareness of electrical safety hazards, you can help to prevent accidents and injuries. Electrical safety is a shared responsibility, and everyone can play a role in creating a safer environment. When dealing with electrical systems and components, always adhere to established safety protocols and best practices. Your commitment to safety is paramount to ensuring a secure and reliable electrical infrastructure.